Hello everyone and welcome to FTB Interactions Remastered, Episode 9. Today we need to automate LV circuits, but not the normal LV circuits that we were making before, but the MV version of the LV circuits, which in itself is an absolutely gigantic rabbit hole, and I can't promise we'll finish it all today, but we'll try. Okay, so I've been through everything to make our integrated logic circuit, and this is the recipe, which looks fairly simple, but it does take us on quite a large tangent. And if I say how many machines we need a lot of machines. So we're going to need one circuit assembler, one extractor, 3 assemblers, one metal bender, one compressor, 2 macerators, 4 centrifuges, 2 MV cutting saws, 1 distillery that's LV and one that's MV, a precision laser engraver, another blast furnace, an electrolyzer MV and LV, a packager, a mixer, a chemical bath, 5 chemical reactors, a thermal evaporation tower, 3 wire mills, an arc furnace, 1 pyrolyzer oven, and an MV extruder, which is a lot of machines, some being multi-blocks, some not being. I don't quite know how prepared we are for this, so maybe we should take it one step at a time. And I think the first step we should do is this integrated circuit, which is the most complicated of all the parts. So, as we are going for the integrated circuit first, let's go through that. So firstly, we need a cutting saw at MV, which is fine. And I think I'm going to go for the distilled water recipe because it uses less EU. Distilled water is literally just water in a distillery, so that's really, really easy, so that's fine. And the thing we need to cut is an integrated logic circuit wafer, which means we need a precision laser engraver. And we can get a higher yield if we are using other wafers, but the second one that we need is HV, so we can't do that, and then it's EV and IV, so we have to stick with the MV recipe for now, which requires a ruby lens, which we can just keep using so we don't have to keep making them, and a silicon wafer. So the silicon wafer is a cutting saw recipe. It also uses the distilled water, which we're already making, and a monocrystalline silicon ball. The monocrystalline silicon ball is the blast furnace recipe, and that requires 2 ingredients: silicon dust and small powers of gallium arsenide dust. Silicon dust we get from electrolyzing stuff at MV tier. I haven't quite decided what I want to electrolyze. I think sodalite might be quite a good one because then we get chlorine gas and aluminium out of it. So maybe that one's a good one. And we also get sodium from it, which yes, that's useful. So maybe we'll go for this recipe and that will get us our silicon. We also need the gallium dust, so we'll need a packager to package it up because we want this to be as automatic as possible. And to get that, it is the mixer recipe with gallium and arsenic. Arsenic's nice and easy for us to get. We just need to electrolyze cobaltite dust, or I think in my case I have chosen to centrifuge realgar because then we get sulfur as well, which will be useful for another part. I think the best yield of gallium we can get at the moment is for a chemical bath recipe, which takes crushed bauxite ore and purifies it, and you get a 70% chance of gallium, which is pretty high. But for that we need sodium persulfate, and to get sodium persulfate we need to electrolyze sodium bisulfate dust, which will give us the persulfate and also some hydrogen. The bisulfate we can get through the chemical reactor, and I've chosen, to be fair, how do I do this? We're going to go for the first recipe, which is salt plus sulfuric acid. To get the salt, I'm going to build a thermal evaporation tower so that we can get salt water, because to get salt water you centrifuge brine. Brine comes from the thermal evaporation tower. We also get some liquid lithium for that, which I'm sure will come in useful later on. We also are going to need sulfuric acid, which is actually a lot easier to get than you would imagine and mainly involves chemical reactors. Let me find the recipe. Chemical reactors. So to get sulfuric acid is just water plus sulfur trioxide. Sulfur trioxide is just oxygen plus sulfur dioxide, and sulfur dioxide is just oxygen plus sulfur, which is honestly really easy. So that should be fine. It's just very complicated. So I think that's the one we're going to go for first. I've written it all down in a notebook. Hopefully I don't get too confused along the way. should be all our single block machines. No, I haven't made any of the turbines yet. I'm still thinking about that, though I think I will probably still just go for steam for now. I think that would be fine. And we have 3 multi-blocks. The thermal evaporation tower will be very cheap. The way to make the blocks is literally just steel and bronze. It takes a little bit of time, but it's actually not too bad, so that shouldn't be a problem. Water is just another end-ending bowl, so that's all good. Electric blast furnace, we've already made one. We need just a copper nickel coil, so that's all right. And a pyrolyzed oven also needs some copper nickel coils. So we need about 32 of these, which is just bronze foil and copper nickel. Wow, we've got quite a lot of all that sort of stuff. So we do need some more liquid tin alloy, which is just iron and tin, so also pretty easy. Luckily for me, after spending last episode making stuff to be able to make us MV energy input hatches, will be making some, because we need at least 3. I think I'm going to make the blast furnace have 2. And then we need one for the pyrolyzed oven because it runs at MV anyway, even though you can go down to ULV. So yeah, not too bad. I'm just making the medium voltage coils right now. We're also making thermal evaporation things and the copper nickel coil block, so it'll take a minute. And I just need to make the ULPIC. However, before I can do that, I'm going to have to find an auto vein in the overworld because we need sapphire to make a sapphire lens to actually be able to cut the wafer. So I'll go do that. Hopefully it won't take me too long. And we also have some silicon wafers that I got from quest rewards, so that'll do us for now when we only need 3 of these. And lucky for me, the auto vein I found is in an abandoned mine shaft, so we'll have to be careful to make sure I don't get killed by something while I'm here. It already sounds pretty terrifying. We are way stronger than the last time I got put in a vein that was mildly infested. Is that a creature? Okay, maybe we can just block up the some of the paths. After a quick dive into the mines, I have some sapphire and we are putting it into the sifting machine, and hopefully we should get what we want. Yes, we need 1 exquisite sapphire to put in the lathe. So fingers crossed. I've just been mining some oil sands and we have our exquisite sapphire. So to make our sapphire lens, we just chuck this in a lathe. I've got an advanced lathe. Oh, it takes a long time. Okay. And ta-da, 1 sapphire lens. So if I chuck this in here with some silicon wafers and a lot of time, we should get our ULPIC wafers. Now, I need to put this in the cutting machine. I completely forgot that. And to do that, why do I need to put water in? There's already water in the cutting machine. That can just go in there and that should cut it. I'm filled up with other things I was making before. But yes, that should very slowly, oh my god, it takes 90 seconds. Cut my ULPIC wafers, and then we should be able to make our MV energy hatches. I forgot this makes actually a few at a time, which is, it's nice. I know we've got too many. Well, never too many. And there we go, 3 of these. And while I was doing that to upgrade my EBF, even though this isn't for my EBF, it's for another EBF, we now have everything to make the pyrolyzed oven and that. I'm not quite sure how many thermal evaporation towers I'm going to need. A fair few. I think the larger is the better. So I've made some more bronze rods to chuck in this thing. I think it needs to be on 4. So hopefully, yeah, we'll get some more casing and just make as many as we can. I have first set up our thermal evaporation tower, and I have just stuck it outside because it's a 4x4 and it's ugly. Why can't it be an odd number? So I've just gone here. Maybe it's just an even number because then you have 2 of them, but we don't need 2 of them. We can get lithium another way. I haven't got any resistive heaters at the moment. I don't know how much we'll need them, but we do need to turn this brine into salt water by using a centrifuge. 2 centrifuges, in fact. I think I'll connect all of that up over here. I do need to make some turbines, etc., etc. So I'll get on to doing that and we'll see how it goes. I've just found out the best thing ever. I can make the little rotor things in an extruder now. I don't need to do it in a complicated way. That's so much better. I nearly started making them the complicated way again because I didn't realize. Woohoo, magical extruder. It takes a little bit of time, but it's so much worth it. I've just been making some mana infused metal for pipes, and I've just realized I was looking through the quests and it says here that actually we can make salt just by using a mold, which yeah, so we miss out on the lithium, but we do actually just need the salt. So for now, actually, that's probably the better option. I think I actually have a fluid solidifier from a quest somewhere as well, so we won't even have to make it. So that's pretty useful. Welcome to my very imperfect system for making integrated circuits. It's not completely perfect at all. I have used individual turbines for each of the machines because when I built this, I kind of forgot. I hadn't read the comments that said that you don't need to have a separate turbine for each machine. So this one does, but I guess future systems won't. And it is a little bit complicated. Okay, now to explain. I did have to fix something there very quickly, but it's working now. So if we go around to the back, we can see that I have made a very big mess with a giant steam pipe, but that's all right. But we do have an important machine, the thermal evaporation tower, which takes water and turns it into brine for us. And it's a little slow. We don't have any resistive heaters, but we've actually got plenty, so it doesn't really matter that this is slow at the moment. We can always add resistive heaters in the future, but this is just producing us brine a little slowly, but it's fine. And here is what I just changed. My blast furnace, even though the recipe I wanted was an MV recipe that takes 120 EU per tick, it wanted more than that. It wants 480. I don't know if it's doing some sort of parallel thing or whatever, but instead I've got 4 MV steam turbines and some mana steel wire connecting it to the blast furnace. So that's what I was changing, and that is the power system. And yes, it's a big mess around here, but that's fine. It's my first sort of automated setup apart from the diesel, which was a lot more simple. And now we get to the mildly confusing front bit, which I haven't actually fully tested because I was waiting for this to run. So we start off with our brine line here, which goes into a fluid solidifier with a mold for balls. And for some reason that turns it into salt. We've got plenty of salt, which goes into a basic chemical reactor. And this reacts with sulfuric acid to get, we get hydrochloric acid, which you shouldn't really have. I need to get rid of that. I know this is rather inefficient, but I can't really do anything with the acid at the moment, so we are just voiding the hydrochloric acid. It's not very expensive. I'm sure it'll be fine. And to get the sulfuric acid, I have a little hopper with sulfur here. Yes, I forgot about the sulfur input. That's why it's like that. I have an electrolyzer, which is electrolyzing water as well over here to get us oxygen. It's very slow, so I've just been filling it up from my other electrolyzer system. I should probably upgrade this to an MV one rather than LV, but I'll do that later. Oxygen goes into these 2 machines while hydrogen just gets voided for now. We also have water going into this chemical reactor. So the first chemical reactor is sulfur plus oxygen makes us sulfur dioxide. The sulfur dioxide goes into another chemical reactor with oxygen to make sulfur trioxide, and that mixes with water to make the sulfuric acid, which goes into this machine. When the salt mixes with the sulfuric acid, we get sodium bisulfate dust, which goes into the basic electrolyzer, which makes us more hydrogen, which is not what we want, and sulfur persulfate. So the hydrogen just buffers into here for now, and the sodium persulfate should go into here, but we had a problem. There we go. So there we go. I've cleared that up now. I don't know why the hydrogen's not going down. I'll put a pump on it. Will that work? Yes. Okay, never mind. Sort of fix that. That will fill up. So we're probably going to have to... I can't put that back in. Oh well. Can I? Yes. Okay. Problems. Crushed bauxite goes in through this hopper. Again, I forgot another input. It's fine. And mixes with sodium persulfate in a chemical bath, which gets us purified bauxite, stone dust, and gallium dust. I haven't actually put any auto exports on any of the item pipes yet. I was testing things. So that's gallium. That's quite a big system just to get gallium, to be quite honest, but there we go. Gallium dust. And this. We're not getting a whole lot of gallium. It's only a 70% chance, but it's better than nothing. On to the next part of the setup. I have real Gargo into this chest, which does have an input, and that goes into a basic centrifuge, which makes us other things, including, which is specifically arsenic, actually, that's what we get from that, which mixes with our gallium dust in a basic mixer, and then is packaged down into small piles of gallium arsenide, which we've actually got plenty of, so that's good. And the other half of the system is for silicon dust. So I've been doing a combination of things. I've been using bentonite and clay dust at the moment. It clay dust gives us aluminium. Bentonite, I'm not quite sure what it gives us as other byproducts. Sodium and magnesium, so I guess they're probably useful. We're avoiding all the water and the hydrogen just because it's easier. I've got some more bentonite sort of forge hammering up, and that's why this is off at the moment. And then once we have enough silicon, it will, I haven't filtered anything, but when I do, it'll go into here and mix with the gallium arsenide, and that's when the really slow thing happens, where you have to wait many seconds, and while I've been talking, it still hasn't finished one round of it, to get ourselves the monocrystalline silicon ball. Once the blast furnace has finished cooking, which does take a very long time, oh good, we've got more silicon to start it off again, we will get our monocrystalline silicon ball. I think we got 2 of them this time, so maybe this is a double processing, I don't really understand. Yeah, so then it goes into the cutting machine. I'm making distilled water with a distillery because why not? It actually reduces the power consumption, so I thought we might as well. And once that's cut, we get silicon wafers, which will need to be put obviously in the precision laser engraver, and we need a lens for that. And now I've remembered, I've got my ruby lens, which should cut our silicon wafers very slowly. And from that, let's just look in the JEI, that should get us integrated logic circuit wafers. Actually a fair amount to be, yes, this is kind of slow, but the amount we're getting is not bad. Like, we've got tons of everything so far. We don't really even need that much more gallium to go with the arsenic. We've pretty much, pretty good on resources, to be honest. So once the laser engraver is done and we get our product, it will go into the advanced cutting machine and quite slowly again cut it for us into the integrated circuit, which is what we need, which is very nice. And finally, ta-da, 8 integrated circuits, which is exactly what this entire wall was meant to be for. So each sort of thing of this gives us 2. Each 2 of the silicon balls gets us 32 silicon wafers. Each silicon wafer will get us 8 integrated circuits. So leaving this running passively, we'll get quite a lot of stuff, which is very nice. So yeah, this is a single component. This is the most complicated component, thank goodness. But there we go. 1 of 6 done. That took me a really long time. Like a really long time. Our next system is for our circuit boards, which is actually much easier than the last one. We have 3 inputs: sticky resin, copper and wood. Copper and wood are fine. Sticky resin's a bit of a pain still, but we'll figure it out. Maybe make another tree farm or something. But we have wood going into a basic macerator to get wood pulp, which is compressed into wood planks. These are some I had from earlier. We have the copper going into a bending machine on circuit 10 to get us copper foils, which go into the assembler as well. And finally, the sticky resin is centrifuged into glue, which is what we need to actually make the circuit boards, and we've already got 10, so that should just, we'll run out of sticky resin at some point. I'll get some more. That should make us circuit boards pretty ad infinitum, and yes, I'm only using 2 turbines for this. Woohoo! I figured out everything. Woohoo! So this one's got its own, and then these 3 or these 4 are sharing one. That's how I did it. I'm sure that's fine. Luckily, the resistor setup fits very snugly next to my circuit board setup. I was originally going to share the sticky resin output from this one with both of the assembly machines, but it's just easier to have 2 centrifuges. So again, we have another centrifuge getting us glue. Just need to auto output it to that side. All the outputs will go into this chest. We are getting lots of raw rubber pulp, which is nice. Still haven't automated the rubber trees. That's fine. We'll get to that. Copper goes in a basic wire mill and gets us fine copper wire, and charcoal goes in a macerator to get us charcoal dust, and that will make us a resistor. We've already got charcoal being made. Oh, we get 2 resistors. No, yeah, 2 resistors. Okay, so there we go. We've already have 53 circuit boards, so yeah, we're doing pretty well. So time for our next update, and I've done it a little bit here. So firstly, we need fine copper wire, which is just made in this wire mill, and we also need tin bolts, which is just made in this advanced extruder with an extruder shape bolt. I've also put in our extractor here, which will extract tin for us, and that will go straight into the circuit assembler. And that's nearly everything that we need. We just need to make one last thing, and that is the diode, which is probably the second most complicated of all the things we need for these MV tier LV circuits. And our final diode setup is up and running. So first we have a pyrolyze oven, which cooks wood into charcoal and wood gas. The wood gas goes into an advanced distillery on circuit 2, which produces us ethylene gas. This mixes with oxygen to get us PTFE. Oh no, it's not PTFE. Polyethylene. Just PE. Ignore the T and the F. We also have copper being annealed in an basic arc furnace. Yes, I am restocking all autumn myself with oxygen is probably fine. That goes into a wire mill on circuit 3 to get fine copper wire. We are taking silicon wafers from the setup over there because I didn't want to have to set up a whole nother system for that because it was so massive anyway. And for that we get diodes, which if I'm sensible we should auto output down here. So now we have diodes, almost completely automatic apart from the oxygen part, but that's fine. We have so much oxygen over there and just none anywhere else, and the electrolyzer is slow unless I do it like this. So there we go. That's everything pretty much. Now we should have everything we need to start crafting our circuits. So if I chuck all of them in there, we have, I don't think this system's going to work quite very well with a hopper, but we'll just chuck it in up here for now anyway. Slowly but surely, we should be producing integrated logic circuits. We did it! Woohoo! Circuits! So yes, now we have the slightly better version of LV circuits, pretty much auto crafting. We can make, yeah, so there's a few inputs and stuff that we need. It'll be easier when we have something like E2 where I can just do it automatically rather than having to put everything in these chests myself, but as you can see at least they're all labelled so that I shouldn't have too much difficulty doing that, but we'll see. But there we go. Oh, that took a long time. I'm very pleased. Hello there, Mr. Cow. If you come to see my circuits, I have changed my hammerhead from cobalt to steel because steel's a lot cheaper to repair. Cobalt was taking 3 cobalt at a time and we don't really get it very easily. Iron, however, we can turn into steel really cheaply and we've got tons of the stuff anyway, so this seemed like a much better change, and it's not that much slower and doesn't have that much less durability, so there wasn't really a big issue in switching them up. I've just been away doing a little bit of mining for our next project, and I just wanted to see how many circuits we'd managed to make, and 3.5 stacks. Nothing wrong with that. That's pretty good in my opinion, so that's great. That's way more efficient than me having to craft them all by hand. We get 2 each time as well, which is even better. So yeah, very pleased with my little system here. So next step potentially might be something to do with the HV age, and to do that I'm going to put pyrolusite, chrome, iron and nickel dust in an advanced mixer, and we're going to wait the 8 seconds it takes for it to mix. What do we get after all that? We get not what I wanted. Okay, let's try this again. So, well, we needed manganese dust anyway, which is one of the reasons it didn't work. And it takes 30 seconds, not 8 seconds, but with a bit of nickel dust, some iron dust and some chrome dust, we should get something pretty nice. Oh, and look, here it is. Stainless steel! Woohoo! Stainless steel. We got stainless steel. And how do we cook it? Well, we need a blast furnace, of course. It takes quite a long time and it runs at HV. So we'll need to get another blast furnace and run it at HV, but I think we actually should be able to do that. And ta-da! We now have another blast furnace, which is making us stainless steel. Yeah, I know I can more share these, but I thought because this one's HV tier and this one's MV tier, that would cause problems, but that's why I'm doing it like this. So we should, after 55 seconds, which is slightly more than the aluminium, finally get some stainless steel. And ta-da! There we go. Stainless steel. High voltage. Woohoo! We are having another steam problem, and the problem isn't, again, that we don't have enough steam, it's the fact that I can't move enough steam over. So we almost had everything there. 1 steel rotor from the extruder, and 1 HV electric pump, which should produce, or at least allow us to pump out a lot more. And now I can connect it and we are pumping steam out at a much faster rate and filling all the pipes, so very useful. And we've made a lot of progress today. Sorry this is a bit of a short episode, but it took a fair bit of time for me to make. Hope you enjoyed it anyway, so thank you all so much for watching and I'll see you all in the next one.